Let me solve a problem to find the value of an elementary function, and then I'm going to prove that the left side equals to the right side. Example: find the Laplace of x. Solution: Laplace of x is the given function. It is actually x to the 1, so which means that this function is in the form of x to the n. It equals to 1 over s to the 1 plus 1. Just apply the first elementary function where the Laplace of x to the n equals to n factorial over s to the n plus 1. The value of n is actually 1 here, but normally we don't write 1. Simply put that 1 here as well. So s to the 1 plus 1 equals to s to the 2, which equals to 1 over s square. So Laplace of x is equal to the 1 over s square. Now I'm going to prove that the left side equals to the right side. Can I write Laplace of x equals to the integral of e to the minus sx times x dx? Well, from the definition of Laplace transform, if you remember, where Laplace of f of x equals to the integral of e to the minus sx times f of x dx, where a is the infinity, because a is approaching to the infinity here as well. So I simply apply the basic formula of Laplace transform here, where my function f of x is x here. So you can see here that it is the product of two functions. One is exponential function and the other is the algebraic function. If we have the product of two terms, normally we apply the integration by parts process here. Now this is the basic formula that we apply in integration by parts process. But since I have one pure algebraic term here, which is x, so I apply the another method. Put differentiation at one side and integration at another side. Take the algebraic term under differentiation and exponential function under integration, which start from minus. Derivative of x is 1. Integration of e to the minus sx equals to minus e to the minus xs or s. Put plus, and derivative of 1 is 0. Integration of minus e to the minus xs or s equals to e to the minus xs or s square, and put minus here. I stop the process here because I got 0 for the differentiation side, and now take cross product between these terms. So this whole thing equals to x times minus e to the minus xs or s minus e to the minus xs or s square, with the limits from 0 to a. This term is the product between these two terms, minus this term equals to the product between these two terms. Expand the limits from 0 to a here, where these two terms equal to 0, and finally are left with 1 over a square. That's how left side equals to the right side. So Laplace of x equals to 1 over a square. Hence it is verified. Let me do some more problems of first elementary condition. Example: find the Laplace of x square. Solution: Laplace of x square, which is the given function, equals to 2 over s to the 2 plus 1. I applied the first elementary condition, which is Laplace of x to the n equals to n factorial over s to the n plus 1, where the value of n is 2. The final answer is 2 over s to the 3. That's how Laplace of x square equals to 2 over s to the 3. Let me solve one more problem of elementary condition. Example: find the Laplace of 3 times x to the 4. Solution: Laplace of 3 times x to the 4, which is the given function, equals to 3 times 4 over s to the 4 plus 1. Again here I just apply the first elementary condition, which equals to Laplace of x to the n equals to n factorial over s to the n plus 1, where the value of n equals to 4. It equals to 12 over s to the 5. That's how Laplace of 3 times x to the 4 equals to 12 over s to the 5.